Good afternoon.
Good afternoon, sir.
Wait, I have put my hand up now. I don't know how to put my hand down. Okay, yeah, I guess. So, just before we start, I want to repeat that coming Monday at 5 p.m. your first class test will be held. All topics covered till today will be part of the syllabus, and you should be ready with clean sheets of paper, and so that you can write the answers to the questions, or at least solve the problems there and be ready. So I think that should be a. So we continue our discussion on yes.
Sir, can we know how many questions and what is the total marks?
Total marks will be some 40 marks. 1 hour test, how many questions means what? In any case, it is 20 marks. Huh? We are going to take 4 tests and best of 3. So 20 marks per test. 1 hour.
Sir, we have to upload the images, or we have to write on the laptop. Like, what will be the pattern?
I will let you know. Be prepared for both. So
okay,
that
sir.
is why I said you have to definitely solve the problems on paper. Otherwise, you won't be able to solve it. So it appears that at least for some of them, you will have to, for part of it, at least you will have to upload, right? Make a PDF and upload. Okay.
Yes, sir.
Has any of the class tests started already?
No, sir. Like, it will be the first.
Okay, good. So we continue our discussion on uncertainty management. So yesterday, we looked at uncertainty in search and optimization. You remember what we discussed yesterday? And where comes the uncertainty in search and optimization? Due to what are the reasons?
Risk.
Due to risk.
Risk.
Environment.
Opponent.
Policy change.
Policy change.
Collaborative agent.
Other agents who may be collaborative or competitive, right?
Yes, sir.
And then there was incompleteness also, which we discussed. And there are two main reasons we found. One is partial observability. That means the full state space or the full scenario is not known to you. So we said some variables are observable and some are not observable. And the other was what does what
actions are not controllable by my side.
Actions, very good. Actions are not deterministic. That means they are not controllable. Not fully controllable, let us say. And how did we model the whole situation then? In the state, we had two kinds of variables, observable and not observable. Secondly, for the state, certain values may be missing. And certain values may be noisy or incorrect values. So one is certain variables are not observable. These are about variables. And these are about values. And in the state space transformation, state transition rules, the state transition rules say that I have two kinds of nodes, isn't it? We define two kinds of nodes. What were they?
And or.
OR nodes and nodes. OR nodes are my decision points, and nodes are other party decision points. And we also said that our solutions at the AND nodes. So at the OR nodes, I know I will optimize something. Minimization, maximization, or a certain risk-based decision. Saying that, okay, if this is the distribution, this is what I will do, etc. And at the AND node, it could be adversarial, where it could be the opposite optimization. That means if I'm maximizing, it will be min or otherwise it will be probability. And then we had our what algorithms? One algorithm we saw was the which was a DFS algorithm, isn't it? Depth first branch and bound algorithm. Our original DFS algorithm moved and became an alpha beta pruning algorithm, which we saw. Is that clear? This is what we discussed last day. Shall I proceed? Shall I proceed?
Yes, sir.
Now we now come to another aspect of AI, which we did not discuss for economics, but it is going to be very important for us going forward. And since we did not get time, we did not discuss it, which is logical deduction. If many of you have seen some of the papers of Amartya Sen and others, you will see that they write down logical formula, which try to describe the current scenario that they are in. They say that if everybody's something happens and that happens or that happens, then this will happen. So causality. So I have written down before we proceed to how we model uncertainty there. And because this is a vast topic, so tell me the answer to this. I make a statement, if tax rate is increased, then there will be more government income. Tax rate is increased, so there will be more government income. Can I conclude this last statement from the first two statements? If my world view, if you tell somebody, if the rule is if the tax rate is increased, then there will be more government income. And you're also informed that the tax rate is increased. So can you not conclude that there will be more government income?
Yes, sir, we can.
Yeah. So this is basic deduction. This is based on Boolean logic. This is based on Boolean logic. Normal logical inference. So how do we do that? We model one Boolean variable A as tax is increased. We model another Boolean variable B as there will be more government income. We model the first sentence as A implies B. You know the meaning of A implies B? A implies B. This implies is the same as, what is it equivalent to, not A or B? A implies B is the same as not A or B. A implies B says if A is true, then B is true. If A is false, I don't know what to say. The second statement, which is F2, says tax rate is increased. And my conclusion is there will be more government income. So what I do is I set up a formula F1 and F2 implies G, and I check for all cases when the left hand side is true, the right hand side must be true. So the left hand side is true. If I draw up the truth table, I will see left hand side is true here and the right hand side is also true. When the left hand side is false, I don't care. So this is the very basic mechanism to show how causality and inference are modeled. So this is how there's a whole world to this. But since I did not get enough lectures, if you all are interested, I can go deeper into this outside of the class. But this is a very deep topic on its own. So let us take another problem. The other statement I make is, if the tax rate is increased, then there will be more government income. Tax rate is not increased, so there will not be more government income. So based on this, given the first statement, if the tax rate is increased, then there will be more government income. The second statement is tax rate is not increased, so there will not be more government income. Can I conclude this?
No, sir.
Why do you say I cannot conclude this?
Because it might be one of the factors,
Yes.
not the only factor.
Yes, so government income can be from other factors, right? So it might be one of the factors. So how do I prove it in logic? Same method. I establish tax rate is increased as a Boolean variable A. There will be more government income, Boolean variable B. First statement is the same as before. A implies B. Second statement, tax rate is not increased, which is not A. And my goal, what I want to derive is this is not true. And I want to prove that A implies B and not A, these together imply not B. And I want to prove that this formula holds. This is how I model causality. This is how I model inference. And I will notice that this is a row where I have A equal to false. That means in a situation where tax rate. So I will have A equal to false, B equal to true. In such a situation, tax rate is this left hand side becomes true and the right hand side becomes false. So this is just to show you how logical deduction happens, and we can write very complex sentences. Very interesting puzzles can be solved, and you can really model a lot of things. So given such a logical and causal reflection, which can be written in many ways, how do we model uncertainty? Normally, any rule, when I say, we have already discussed this, the state transformation rules. So I say, if I say A implies B, then instead of saying A implies B with certainty, I will say A implies B with 0.8 probability and not B with how much?
0.2.
0.2. So I include probabilistic component in causality. And once I have this probabilistic component in causality, immediately I can start reasoning about uncertain information. Uncertain information, and I can start modeling. Where will I get the probabilities from? Where will I get the probabilities from?
Whole data.
Yes, past data or domain knowledge. There is another argument, another way of modeling uncertainty, which we shall not discuss, which is called fuzzy. Fuzzy logic. So one is probabilistic logic, where probabilities are associated. In fuzzy logic, this is also called possibility theory. Is based on the notion of graded truth. Whereas probability, in probability an event happens and there is a probability or a chance associated with that event happening. But the event is either true or false. The outcome of the event is either is a crisp value. Whereas in fuzzy logic, the outcome itself is vague. That means the outcome itself, you say if the coin is tossed, it is 0.7 head, like that. So though that is not applicable for a coin tossing, but it is applicable for other areas. But we shall not discuss it. The third place where all this is very well modeled is in neural networks. And in statistical inference. And I think these part will be discussed later on in other modules. Of this course. Today, I shall very quickly go through this very interesting part of AI where you use causality and probabilistic reasoning, and that is called belief networks. Belief or Bayesian networks. That is what I shall introduce to you today. So Bayesian networks are hinged on probability and causality. For example, here we have certain, say we have crop type. Now, depending the productivity depends on the crop type, and the nutrient load on the river also depends on the crop type. But the nutrient load on the river also depends on the irrigation efficiency and the total irrigation area which is loaded onto the river. Similarly, the river water quality depends on the nutrient quality, the river flow. Based on these two, the river water quality happens, and the fish population. The fish population here depends on the quality of the river. These are like the implications that I just showed you. A implies B. But we want to model that this A implies B with probabilities that we just mentioned. Now let us go to the links and their meanings. Here is another example. It says that the state of the battery indicates whether the radio will be on or the ignition will be on. Now, if the battery is low, then both will not be on. On the other hand, if there is no petrol and there is no ignition, the car will not start. Now you can notice from this diagram here that here there are these links which you could have drawn, causality links which you could have drawn in many ways. Whether there is petrol and whether the radio plays are independent given the evidence of whether the ignition takes place. Whether the radio plays or whether there is petrol is independent of this ignition because it is not influencing it in any way. Petrol and radio are independent if it is known whether the battery works. Petrol and radio are also independent given no evidence. But they are dependent given whether the car starts. If the car does not start, then the radio playing is increased evidence that we are out of petrol. That means the car has not started and the radio is playing, which means what? Which is working?
Sir, battery.
Battery is working. And because battery is working, therefore ignition is not expected to fail. Therefore, the only reason why car is not starting is probably because the petrol is not. So this is how the reasoning happens. Here is a detailed, complicated network on economics. There are lots and lots of papers on using on solving economics problems using Bayesian networks. There are books. You can have a look. There are many books and there are lots and lots of research articles. For example, this one says, given the land and farming options, the local employment, the quality of woods available to the market, the management cost, the quantity of fish available, coastal protection, farm pollution. Now that affects the typhoons, that affects the risk of juvenile escape in waterways, local subsistence capacity. And then if you go down, then it starts showing a detailed diagram which ends in the various values of the agricultural profit, the shrimp exports, the resilience of the local community, biodiversity, etc. So what I'm just trying to say is that based on the problem at hand, people can develop very detailed belief networks. Nowadays, many of these problems, if you also have a lot of data, are solved by these data science and the deep neural networks. But the advantage of belief networks is that it provides you a detailed explanation and why this thing happened, because it is founded on probability. Now, how do probabilities get assigned? So here is an example. Here is an example which indicates how probabilities get assigned. This is an example of suicide rates, how suicides occur and what happens. So my end goal is this, the probability of suicide. And these are just some values. So it says probability of breakup is given as 0.2 and probability of not breakup will be
0.8.
0.8. Probability of relative loss is 0.1 and therefore probability of relative not being lost for in average is 0.9. Now emotional shock. Emotional shock depends on breakup and relative loss. And the table, the probability table is given here. It says that if both are true, it is 0.85. If breakup and this one is false, it is 0.4. If it is breakup is false and this is true, it is 0.6. And if both are false, then it is 0.05. Similarly, we have two more independent variables in this model. Financial problem, probability of it being true is 0.3, false is 0.7. Similarly, work pressure. So stress is modeled here as dependent on financial problem and pressure. And if both are there, it is 0.95. When FNP is true and PRS is false, it's 0.8. When PRS is false and FNP is false and PRS is true, it is 0.6 and both are false, it is 0.1. Another independent variable is no family and friends, which is 50%. And that an emotional shock leads to depression. So here are the probability tables for depression. Similarly, you have another end variable, which is insomnia, which is an outcome variable. There is another independent entity, which is serious illness. And then from that serious illness, there is a possibility of a prior stroke. And all these three, depression, chronic stress, and prior stroke, are the three influencers who influence suicide. And the probability values are given for them. So this is how the probability assignments are done. Any questions here? And this, as I said, comes from past data, experiments, and domain knowledge. Either experts will tell you this is what is their understanding, or in many cases of problems which lead, so sometimes even your mathematics will tell you that this is what the probability is. When you set up your model, when you set up an equation or some model and come up with some simplified equations, you may get this model. Any questions? Anybody? Sunidhi? Yeah. What were you saying?
Interesting to see like how if all three are true, then also it's 0.8. But
yeah, so this is what they have given. This is some data I copied. This is interesting because typically, what he's saying is that, I also noticed these 2 points you're saying, no?
yes, sir.
I also noticed, but that is what they got. They're presented, so I didn't change it. So now let us come to another example from which, oh no. Yeah. So let us come to this example. So I have taken 5 variables, B, E, A, J, M, and probability of B is 0.1, so 0.001. So probability of not B is
0.999.
correct, 999. probability of E is 0.002, so not E. Now, given B and E, I can find out I am given the probability of PA. And given PA, I am given the separate probabilities of PJ and PM. Is this table understood by everybody? Gyan Ranjan Pradhan, are you there?
Yes, sir.
Table is understood.
Yes, sir.
Okay. So now, once we have this, now we can answer many questions. We want to know what is the probability that J is true and M is true and A is true and B is not true and E is not true. Now, since we know who is dependent on what and the tables are given, so P, J, M, A, not B, not E can be solved as Pj. I know I can get from Pj given A because A is true. So I don't need to bother about not A. Then Pm, I need to only look at Pm given A. Then Pa, I need to only look at not B and not C case. And then I need to look at the not B and not E case, and I need to look at the not E case. So I can based on the diagram that I have, I can replace this first step, by the second step. Has everybody understood how to calculate this?
Sir, why we didn't check for not A? What did you tell?
Because it is told, no? You are told that A is true. Pj and M and A and not B and not E. If I was told Pj and M and not B and not E, then I would have to break it up into two cases, A true and A false. Suppose I was asked P, J and M and not B and not E, then I would have had to break it up into two cases. One case would be this. Can anybody tell me what would be the other case?
For not A.
Right. So then I would have had to add these two up. Got it? Who asked this
Yes,
question previously?
Sir, I, sir. Akshat.
Got it, na?
Yes, sir. Yes, sir.
So that is taken care of in the next one. If I want to independently know PA, then I have to look at all the possibilities. And for A, I only need to look at B and E. Because A is dependent on B and E in this causality diagram. I don't need to look at what is the outcome of A given J. That is the reverse hypothesis that I will derive. But to just find PA, to answer your question, I need to look at these four cases. And PA given not B and not E is PA given not B and not E is the same as what? PA given not B, sorry, PA given not B and not E into what?
Probability of not B, not E, but they are independent, so we can break.
Yes.
Is that what you're saying?
Yes, sir.
Correct. Similarly, I can break this up. Similarly, I can break this up, and I will get this value. Anybody has a doubt? Gaurav, Meena, are you there?
Yes, sir.
Clear, right? Very good. So now let us do another one. Let us try to find out Pj. How will I find out Pj? How will I find out Pj? Tell me, anybody? Pj.
Sir, Pj is equal to Pj given A plus Pj given not A.
Very good. Pj A plus Pj not A. Is it clear to everybody? Nitin Kohli? Are you there? Parth Tusham? Are you there?
Yes, sir, I'm there.
Yes. Is it clear? Now write down. The next PJA, how do you write? Correct. The next one will be Pj not A, will be Pj given not A into P not A. PA we have just found out. PJ we have just found out. PA we have just found out. So correct. So PA we have just found out in the previous page. So now we find this. How will you find PAB? How will you find PAB? All of you do. Can anybody tell me how to find PAB?
Sir, P A given B into PB.
Anything else? Kushal, Natani?
No, sir, I think this is fine.
Good. What about E? A doesn't, like you told me last time, doesn't A depend on E also?
Yes, sir, it depends.
So you have to also add P, A, B. So in each of this, is this correct? This has to be written down as P of A, B, E plus P of A, tell me?
A, B, E not.
E bar. Now this is written as P A given B into PB into PE plus PA what else?
P A given B into PB.
PA given BE. PA given BE bar into PB into PB bar. Correct? Sorry, E bar. Is everybody with me or not? Pankuri, are you there?
Yes, sir.
This is clear.
Yes, sir.
Why this is wrong is clear.
Yes, sir. We should have also taken into account the effect of E.
E, because A is influenced, directly influenced by, so we only look at those which are direct influences. So this is wrong, this is right. This is correct. And this is wrong. Good.
Sir.
Yes.
So whether, sir, if there was something from also B, then whether will it affect in this or not PAB?
Something for B means somebody
like,
else was having something to B.
No, so, no, like from B, yeah, somebody else having from B, like there is D, which is just
D, which has got an A, say you want to say there is a direct, that is D, and there is an outgoing edge from B to D or an incoming edge?
outgoing, sir.
If it is outgoing, then B, only B will be PB you have to calculate. PB, calculation of PB is what is important for A. Now, whether if there is an incoming edge from D to B, then for PB you have to use D.
Okay.
If there is, got it? That is how, like here. Here, how did we compute PA? PA, we got 0.0025. We got it by a detailed calculation. No?
Yes, sir.
So you have to calculate it. Here it is independent. Pooja Bhagwan, are you there? Oh, somebody had a question. Kushal.
Yes, sir. Sir, the above, like PA into B is equal to PA given B times PB should also be right? But like PA given B can be expressed as this.
No. Here in this diagram, if you look at the diagram,
yes, sir.
PAB, A is true and B is true. These are not the only events. When you talk about standard probability theory, saying that there are two events A and B, therefore PAB is PA given B into PB. But here there are more events, no?
So like we have to calculate PA given B by using the like considering E, but writing the
equation.
This equation, you're saying that this equation is right. Kushal, is that what you're saying?
Sir, I'm saying that like we have to write PA given B has to be written considering E, but the above equation I think should be right. Because like if we represent PA given B, like in the next equation in the second one, if we take B common, then
No. There are two parts to that. Remember, there is this part and there is this part. All right. Look at PA given BE and PA given BE bar. They don't add up to 1.
So but multiplying PA given BE times PE plus PA given BE bar times PE bar should add up to PA given B.
That is what this whole thing adds up to PAAB.
Yeah.
No, PA given B depends on the value of, say, PA given B.
Yes, sir.
To find this, I need to find out what is E, na?
Yes, sir. Yes, sir.
To find out PA given B, I need to work out both cases of E.
Yes, sir. But like I was saying, then like if we write the above equation and like it should hold true. If we compute PA given B, that we have to compute using E. But if we have already computed PA given B, then the above equation.
Yeah, if we have computed PA given B independent, if this has been computed given, if this has been computed, I got your point now. Considering E, then it is fine. Is that what you're saying?
Yes, sir.
Got it, right?
Yes, sir.
Clear now?
Yes,
so
sir.
It depends on whether this PA given B, how it is computed. It is wrong if it is computed wrongly, if it is right if it is computed rightly.
Yes, sir.
Good. Very good. Now let us do this inference. Let us try to find out P J given B. How will I find P J given B? Prabhu, S. Prabhu.
Yes, sir.
How will I find P J given B?
Probably, I mean, P of
J, I mean P of B into P of J given B bar.
You're given B though. You're told that I want to find the probability of J given that B is true.
Okay,
Which other variables you have to consider?
we should consider A also.
Obviously, without A, how will you get anything? And
Sir, also E. So we should consider E also to calculate A.
good. So what will be how will we calculate?
For sir, like we will take E or E naught, and B will be true. So we will find the A and
A bar.
and
You have to do A
yeah.
bar.
Yes, sir, A or A bar, and after that we will find J.
Correct. Good. And how will you find Pj given? So you first find Pjb, and then you can do it this way or the way you mentioned. The way you mentioned is also possible. You know, you work out the way you mentioned is very good. P, J, what are the cases? J, A, B,
E bar
plus P, J, A, B, E bar plus P,
J A bar
J, A bar, B, E plus P, J, A bar, B, E bar. These are the four mutually exclusive cases. Can you quickly do this and tell me whether this answer is coming correctly or not?
Sir, I am little bit confused. Like, sir, what's the difference between sir JB? Like JB is J intersection B, or like I'm not
J
getting.
and B, JB is J and B.
Okay, fine.
PJB is PJ and PJ is PJ and B. Good. Now the outcome probability, outcome event, we said probability of true and false. That means in this case, this row means that if B is true, E is true, A being true is 95% and A being false is 5%. Now we can have cases where there can be more than one outcome. That means here is your class test, difficulty, intelligence, grade, gate, letter, whatever. So let us look at difficulty, intelligence, grade. This part only. So here the outcomes are 3. There can be 3 grades. Previously we were saying either PI is true or PB is true. But now, given the difficulty and the intelligence, what is the chance of getting grade G1? What is the chance of getting grade G2? What is the chance of getting grade G3? This sum will be 1. This sum will be 1. Previously it was true or false, but now it can be having multiple values. So when you go to multiple values, then you just have instead of true false, instead of being G1 and G1 true G1 false or grade true grade false, now you have 3 grades. Chances are 50% of if you're it is difficult and highly your intelligence, then it's 50% to grade 1, 30 to grade 2, grade 3. If you're intelligent, if you're it is difficult and your intelligence level is false, grade 1 must be the lower grade, obviously. And if it is easy and you are very intelligent, then the higher grade, this is the higher grade. So this is how you compute. So with this, I will stop today. Pulak, are you there?
No, sir. Pulla couldn't make it. He has left for a meeting, urgent meeting.
Okay, Nayak, you're there. Yeah. So regarding the test, they will have the test in Teams only, right?
Yes, sir. Yes.
So all of you, please join 5 minutes beforehand, if possible. How many of you have a class before that at 5 o'clock? Anybody has a class before 5 o'clock? Yeah, yes. Many of you have. Okay, then we'll do one thing. You join at 5, and then we'll get ready and we'll find out a way to solve the problem. And just before concluding, you know, this logic has got many more details. We just did Boolean logic, but logical inference has got much more than that. And I forgot to tell you that this logical inference has got much more than that. And while we did only Boolean level probabilistic logic, there is higher logic called predicate logic, where you can formulate sentences in a much more deeper form, like saying no contractors are dependable, some engineers are contractors, and then you want to conclude, therefore some engineers are not dependable. So you can go into a much more detailed logic, which is predicate logic, and introducing probabilities in that predicate logic again and applying it to economics is another very open problem and very interesting problem, but that is out of scope for our current module. So thank you very much. If you have any questions, I'll try to answer. Otherwise, we can wind up for today, and best of luck for the exam. Nayak, you want to say anything?
No, sir. I think you have already said the timing. They can join exactly at 5, and then we can start after 5 minutes or so.
Yeah.
So, and the exam will be for about 45 minutes or so. Depending upon the time slot available, we'll plan the things.
Yeah, I have told them maximum up to 1 hour exam can be there.
Yeah, maximum 1 hour.
Swapnil, you had any question, or you had raised your hand when I asked whether you have a class till 5?
For the class.
Okay, then, if there are no further questions, wasn't this an interesting topic? This Bayesian networks, straight, simple, but I thought it was useful. I would suggest you all do one thing. You all try to formulate a small problem of your own in economics using belief networks. Do it as an exercise. Can anybody suggest what could such a problem be?
Between like multiple good choices, what one particular good should produce.
Example, what sort of goods?
Sir, so it could be like we have some labor and certain raw materials whose availability might depend on, might be probabilistic. For example, suppose we have a supply of cotton, we could either use it to make bed sheets, or we could use it to make clothes. And then there could be factors like say if the weather is warm, then maybe more people would go for cotton clothes. So weather could be one variable. Then we could have something about.
Very good, very good, very good. Good think. So this will give you, this is a good, you're getting an idea. Others also please think of your own problems which you can formulate using this. Dhruv Joshi, are you there?
Yes, sir.
Could you follow? Could you follow the class?
Sir, yes, sir.
Okay. Okay, then thank you everybody. Bye.
Sir, do we have a class tomorrow?
Tomorrow no class.
Okay, sir.